Welcome. In this video I'm going to show you how you can perform a post-hoc residual analysis after a goodness-of-fit test using binary tests. It's also possible to use goodness-of-fit tests. I have a separate video on that. Or use a pairwise comparison. So the residual just looks at the categories and their expected counts, while a pairwise would compare each possible combination of categories. In this video I'll be using R and my stikpetR library. I'm currently using R version 4.3, and as you can see I only have the default packages installed. So this video will focus on just how to obtain the output. To show you that I'll need some example data. So I have a file from the General Social Survey from 2012, slightly adjusted for example purposes. I actually don't need all its data, I just need one nominal field, so I'm going to be using the nominal field and then mar1 for marital status. To give you a quick impression of this, the table will be stored under Fi for frequencies, and as you can see 79 people indicated to be separated. Now my library is available via DevTools, install GitHub, and then stikpet/stikpetR. And once you've installed it, you can load it just as any other library. The function of interest is actually at the moment pH residual goodness-of-fit bin for binary. And although it's missing here, there's also an additional option to change the multiple testing correction, MTC. I'll add it in the documentation later. You can also specify which test you actually want to perform, either a standardized residual, adjusted standardized residual, binomial, Wold, or score test. So just to show you how this will look like, here's the output. As you can see, it shows the different categories, the observed counts, the expected counts. I didn't specify them, so it will assume each category to have the same expected count. The test statistic, in this case that's the Z value because it's using the standardized residual Z test as the default test. Then the p-value and the adjusted one. The default for adjustment is Bonferroni, but as mentioned earlier, you can these days change it by setting the MTC parameter. In this case, it looks like all of them seem to be below the usual threshold of 0.05, so we would say that only never married was not significantly different. All the other ones were significantly different from their expected counts. If you do have some expected counts up front, for example these, then you can add them as one data frame as shown here. And then you can actually add that as a parameter into the function, and then it will use those appropriately. And as you can see now with those expected counts, it seems like most of them are now below the usual threshold, or actually only the first two, married and never married. This one isn't. The E minus 0.1 means we need to divide this by 10 to the power of 1, so this will be 0.89 and this will be 0.10, so above the usual threshold of 0.05. Alright, and I guess that's about it for this video. I hope this was helpful, and thank you for watching.